example, you can have a system like x plus y minus 2z equals 1 and y plus z equals 2. Okay, so the number of variables is 3, the number of equations is 2, and it's an underdetermined system. The reason why it's called underdetermined is that imagine if I were to say that z is equal to a, where a is some number, whatever number I pick. Then I know that y is going to be 2 minus a, and I can take these two values, plug it in here, and get another answer for x, which will be in terms of a. Okay, which will be in terms of a. And this is underdetermined because what it means is that I can pick any number for a and I can get an answer for x and y. Pick another number for a and I get another set for x and y. So it's underdetermined. I can't fix a value for x, y, and z. Okay, just one set of triplets cannot do that. So that's why it's underdetermined. In the case of where the number of variables is less than the number of equations, it's an overdetermined system. So for example, let's say I had x plus y equals in 2 equations equals 3, x minus 2y equals 6, and x plus 3y equals minus 5. I've got 2 variables, okay, but 3 equations, and the system is called overdetermined. It's called overdetermined. Okay, the number of variables is less than the number of equations. All right, let's see what we do with these. Example of an underdetermined system, which is to say that there are more variables than equations, and let's see how we solve that. Okay, so here's an example. Let me go get my snipping tool. I'll snip that. And so here's my original system. It's got 3 variables, x, y, z, and 2 equations. And I'm going to perform elementary row operations. So remember what I showed you earlier. In an underdetermined system, you will have many solutions, and I'll show you how that happens here in a minute. Okay. So doing my row echelon form, okay, I want to make this guy a 0. Here's my move. Here's my resulting system. Okay, this is alt. This is new. Okay. Since I want ones on the main diagonal, so this would be like your main diagonal, I'm going to divide this equation by 3 and I get this resulting equation here. Okay. So now again I have 3 variables but 2 equations, and I can't solve uniquely for it. So what I'm going to do is I'm going to arbitrarily say that z is equal to a, which gives me that y is equal to a minus 1. I will take these values of y and z and plug them in here and solve for x. So I get x equals 2 plus 2y minus z, okay, by moving this over, okay. And now I can come in and substitute for y and z in here, and I get 2 plus 2 times a minus 1 minus a, okay, which gives me 2 plus 2a minus 2 minus a, which gives me a. So my answers are x is a, y could be a minus 1, z is a. Okay, so for example, a could be 1.0235. Okay, then a minus 1 would be 0.0235. And you can pick any number and you can get a triplet out of there, and that triplet will satisfy the original set of equations that you have, okay, if you've done your work correctly. Okay, so that's an underdetermined system. Okay, that's it for 7.3, the first part of it. I'm going to then record 7.3, the second part of it, which is partial fractions, as a separate lecture, okay?